Although many newer agents are available, water remains the #1 extinguishing agent used in firefighting because of its universal abundance and ability to absorb heat. Water is also preferred because it can be moved long distances and is easily stored.
Water!
Water supply is an important element of pre-incident planning, which should attempt to identify all sources of water supply. This should include hydrants as well as alternative water supplies for situations in which water systems are unable to provide an adequate supply to extinguish the fire. In this program on water supplies, you will see how water gets from the original supply to a fire hydrant and how hydrants operate. We'll also demonstrate a test to ensure the safety and reliability of hose conveying water to the scene. The learning objectives are to present the components of a modern water system, to describe the parts of a water distribution system, to describe valves in water distribution systems, to define terms used in measuring water pressure, to show the operation of 2 types of hydrants, and to demonstrate how to conduct a service test for a fire hose. Public and private water systems supply water to most of the more populated areas in the U.S. and Canada. Although individual water systems vary, all systems contain the same fundamental components: a source of supply, a means of moving the water, processing or treatment facilities to purify the water, and a distribution system, including storage. Let's look a little closer at each of these components. The source of supply will be either surface or groundwater or both. Surface water supply includes rivers or lakes. Groundwater supply can be wells or springs. Water moves in a water distribution system in 3 ways: direct pumping, gravity, or a combination of both gravity and direct pumping. The direct pumping system uses 1 or more pumps that take water from the primary source and discharge it through the filter and treatment processes. From this point, pumps force the water into the distribution system. Backup pumps and secondary power sources are usually needed in the direct pump system to assure uninterrupted service. In a gravity system, the water source is located at a higher elevation than the distribution system. The force of gravity provides the pressure. Most communities use a combination system. This system uses both the direct pumping and gravity systems. Water is stored in elevated storage tanks. During periods of low consumption, the tanks provide pressure through gravity. Many systems use ground-level storage rather than elevated storage. In that case, the water is pumped into and out of storage. When water demand is high, the pressure is provided by direct pumps backed up by additional water from the storage tanks. Water processing or treatment facilities are necessary to remove contaminants that could pose health risks. The fire department's primary concern regarding treatment facilities is that the treatment process can be slowed or stopped by a maintenance error, natural disaster, loss of power, or fire. This would drastically reduce the volume and pressure of the water available for firefighting operations. Another problem would be if the treatment system could not process water fast enough to meet the demand. In either case, your department should have a plan to deal with any potential shortfall. The distribution system of the water supply system is the part that receives water from the pumping station and delivers it throughout the area served. The ability of the water system to deliver an adequate quantity of water depends on the capacity of the system's network of underground pipes called mains. When water flows through the pipes, it loses pressure due to friction. This friction loss can be lessened if the system is a circulating feed system, which means that hydrants are supplied by more than one direction. A distribution system that provides circulating feed from several mains is called a grid system. A grid system consists of the following: primary feeders, which are the largest pipes in the system and move large quantities of water to various points in the system; secondary feeders, which are the network of intermediate-sized pipes that reinforce the grid; and distributors, which are the smaller mains that serve individual fire hydrants and blocks of consumers. Other factors that create friction loss are minerals encrusted on the interior surface of the pipe and sediment that drops out of the water. Valves play an important role in water distribution systems by controlling the flow of water through the piping. Valves should be operated at least once a year to keep them in good condition and to ensure that valves remain fully open. Valves should be spaced so that only a minimum length of pipe will be out of service if an area needs to be shut down. One important factor in the effectiveness of a water supply system is the water department's ability to quickly open valves for the fire department when increased flow is needed, or to shut off valves during an emergency. A well-run water utility has records of the location of all valves, as well as the direction to turn and number of turns required to open or close each valve. If the fire department is responsible for hydrant inspections, it should note the condition and accessibility of the valves and report this information back to the utility. Valves for water systems are divided into two main groups: indicating and non-indicating. An indicating valve visually shows whether the gate or valve seat is open, closed, or partially closed. Non-indicating valves for water systems are normally buried or installed in manholes. A buried valve is still usually operable above ground with a valve box key. Control valves in water systems may be either gate valves or butterfly valves. Gate valves should be marked with a number that indicates the number of turns necessary to completely close the valve. If the valve resists turning after less than the number of turns marked, it may be clogged with debris or another obstruction. Butterfly valves usually have a rubber or rubber composition seat that is bonded to the valve body. The valve disc rotates 90 degrees from the fully open to the fully shut position. Understanding the terms used to measure water pressure is basic to water supply operations. The term pressure is defined for fire service use as the force that moves water through a pipe or hose. This pressure is measured in pounds per square inch, or PSI, or in metric terms in kilopascals, or kPa. In some countries and in NFPA documents, metric pressure is measured in bar. There are three types of water pressure that the fire service is most concerned with. They are static pressure, residual pressure, and flow pressure. Static pressure is the pressure of non-moving water. Static pressure is the stored potential energy that can force water through mains, valves, hydrants, and fire hose. Since true static pressure is rarely found in a water supply system, this term is also used for the normal pressure existing on a system before the flow hydrant is opened. Residual pressure is the pressure that is left in a distribution system at a specific location when a quantity of water is flowing. Residual pressure is that part of the total available pressure that is not used to overcome friction or gravity in forcing the water through pipe, hose, and other conduits. And finally, flow pressure. Flow pressure is the forward velocity of a water stream at a discharge opening. Flow pressure is determined when we measure the discharge from a hydrant with a pitot tube or electronic flow meter. Fire hydrants provide a primary source of water in areas served by water distribution systems. The two main types of hydrants are the dry barrel and the wet barrel. The dry barrel hydrant, also known as a frost-proof hydrant, is used in climates where freezing is expected. The valve holding back the water is underground. The valve should be positioned below the anticipated frost line for that area. When the hydrant is closed, the barrel from the top of the hydrant down to the valve should be empty. Any water that remains in a closed dry barrel hydrant will drain through a small drain valve or drain outlet at the bottom near the main valve. This drain valve is very important to proper hydrant operation. It is open when the hydrant is not flowing and then shuts when the hydrant is open. For this reason, it is essential that you open dry barrel hydrants completely when operating them. Otherwise, the drain valve will remain partly open and water will flow out of the hydrant, causing erosion. Likewise, you need to completely close the hydrant to be sure that the drain valve opens all the way to allow the excess water to drain. To shut down a dry hydrant, turn the wrench slowly to close the hydrant valve. Drain the hose and disconnect from the hydrant outlet. Cap all of the discharges except for one. Leave that outlet open until the hydrant is fully drained. To verify it is draining, you can put your hand over the uncapped discharge. You should feel a slight vacuum pressure pulling on your palm. Replace the cap when the hydrant is drained. Wet barrel hydrants are used in areas that do not have freezing weather. Wet barrel hydrants usually have a separate valve for each outlet. The wet barrel hydrant is always filled with water up to the valves that control the discharge.
Opening hydrant!
The amount of flow from a hydrant can vary for many reasons. First, the proximity and size of the mains that feed the hydrant will have a major impact on the amount of flow. Also, sediments and deposits within the distribution system will increase resistance to water flow. This is especially true in older water systems, where deposits have built up over a long time. It is important to know the flow rates of hydrants in your jurisdiction and to know all hydrants that are out of service or being repaired. Fire hose must be service tested at least once a year according to the guidelines in NFPA 1962. Service testing is also required when hose is potentially damaged in service and after repairs. Now, let's look at how to service test fire hose with a fire apparatus pump. Before any service test, the hose should be inspected for visible signs of damage. Remove any hose that fails the visual inspection and tag it out of service. Also, make sure all the hose in the test layout has the same service test pressure. Old hose may have a lower service test pressure than new hose of the same size. Check all gaskets and replace any that are missing or defective. And then connect the sections of the hose test layout. The test layout should be no greater than 300 feet or 90 meters with no kinks or twists. When testing with an apparatus pump or portable pump, you must use a hose test gate valve. This special valve has a 1/4 inch or 6.4 millimeter hole in the gate that prevents water from surging through the hose if it fails. Connect an open test gate valve to each discharge valve, and then connect a test length of hose to each test gate valve. Tighten the connections with a spanner wrench. Tie a rope hose tool, hose strap, or rope 10 to 15 inches or 250 to 375 millimeters from the test gate valve connection. Secure it to the discharge or other anchor on the apparatus. Attach a nozzle with a non-twisting shutoff valve or bleeder valve to the far end of the hose layout. Gradually raise the pressure to 40 to 50 psi or 280 to 350 kPa, or to hydrant pressure. Open the nozzle or bleeder valve to purge the air from the hose. Make sure the nozzle or bleeder valve is above the height of the pump to permit all the air to discharge. Then close the nozzle or bleeder valve. Check the test layout for leaks and tighten couplings if necessary. Mark the hose at the point where the jacket connects to it behind the coupling. Secure the hose behind the nozzle or bleeder valve to prevent uncontrolled reactions during the pressure test. Close each test gate valve. The hose line is now ready to be tested at test pressure specified by NFPA 1962. The hose is slowly brought up to the test pressure while it is closely monitored for leaks. At any time, if the hose bursts or leaks, the pressure test is stopped. Maintain a safe distance while conducting your inspection, at least 15 feet or 4.5 meters to the side of the nearest hose. After 3 minutes, slowly reduce pressure, close each discharge valve, and shut off the pump. Open each nozzle slowly to bleed off pressure. Disconnect all hose connections and drain water from the test area. Inspect each hose where it was marked at the coupling. The coupling should be in the same place. If it has slipped, tag the hose for recoupling. Tag and remove all hose that has leaked or failed in any other way, and record the date and test results for each section of hose. A stationary pump or hose testing machine may also be used to service test hose. Hose testing machines have several advantages. They can maintain a higher range of test pressures and are equipped with automatic check valves that restrict volume from flowing if a hose breaks. Refer to NFPA 1962, your department's SOPs, and directions from the manufacturer for conducting tests using a hose testing machine.
Opening hydrant!
Firefighters must understand the water distribution systems and alternative water supplies in their response area, so they are able to tap these sources as rapidly as possible for fire attack. A burst section of hose during fire attack is a serious situation. The interruption of the water supply under fire conditions can place firefighters as well as any occupants inside the fire in grave danger. In this program, you have seen many important aspects of water supply systems used in firefighting. We have shown the components of a modern water system, the parts of a water distribution system, valves that control water flow, and the terms used in measuring water pressure. We have also shown the operation of 2 types of hydrants and the procedure for conducting a service test of fire hose. Water supply may not be the most glamorous duty of a firefighter, but it is critical to the entire team's success and safety. Firefighters at the nozzle can't put out the fire without it, and their lives may be in jeopardy if the water supply is unexpectedly cut off.